Okay, we are on lesson number 4, special cases, and we're going to still be talking about both inequalities and equations. So what I did was make a table in my notebook. I went the whole page. Don't worry about making it look so fancy, but this is how I decided to break it up. So here are the first 2 problems. Feel free to pause it if you need to copy them down, and we're going to work through solving them. Now you have learned how to solve all equations and inequalities now, 1-step, 2-step, and multi-step. So there's going to be a variety of them on this today. So if I want to look at solving this equation over here, I'm going to first see if there's any distribution, and there's not. Then I'm going to check to see if there's any like terms. Well, 5r and 3 are not like terms, and -3 and 2r are not like terms. That means that I cannot combine anything. So now what I'm going to do is use my inverse operations to move different pieces to opposite sides. So if I look, I have a 5r here, and I have a positive 2r here. Remember, it's always the sign in front. So if I want to move this positive 2r here, and here's my line in the middle, I need to do the opposite operation, the inverse, which is subtraction. So whatever I do to one side, minus 2r, I have to do to the other. Not here, because they're not like terms, with the actual other variable, the same variable r. And I'll draw my line across to keep it nice and neat. So I do 5 minus 2, and I get 3r minus 3 equals -3. Okay, so here's my variable now. Well, there's no other r's anywhere, so now I want to start to isolate this and get it by itself. So this says subtract 3, so I'm going to do the inverse and add 3. So I bring down my 3r. These cancel out. I get equals. -3 plus 3 is 0. That's okay. 0 is a number. So now if I box my variable again, well, when 3 and r are right next to each other, that means multiplication. So the inverse operation is division. Remember, this symbol means to divide. So I'm going to divide by 3 here. I'm going to divide by 3 here. These will cancel. I'll get just r equals. And when I do 0 divided by 3, it's going to tell me 0. So my answer here is r equals 0. Remember, 0 is a number, so that doesn't mean that there's no solution. It just means that 0 is the solution. So that's what it could look like for an equation. An inequality is going to look very similar. Here's my line. Here's a variable, and here's a variable. You notice I'm boxing the sign that's in front with it. So now I look at this, no distribution. These are not like terms on the left side. These are not like terms on the right side. So now I can start to move things. So if I want to move the positive 6x to the other side, I'm going to make it a -6x here and here, or subtract, either way. So I bring down my -8. I didn't use it. Okay, if I do -16 minus 6, I get -22x, greater than or equal to -8. Okay, let me box my variable again. So this is the only variable. So now I have to get rid of this -8 or -8 by doing the inverse, which is add 8 here and add 8 here. These cancel. I get -22x is greater than or equal to -8 plus 8 is 0 again. Still have to get the x by itself. I'm not done. How do I get rid of the -22? Well, remember when they're right next to each other, a number and a variable means multiply. So I need to divide, and there's my divide symbol. Divide by -22, divide by -22. So I get x. Now remember, I divided by a negative. That means I have to flip the sign because I'm dividing by a negative. So this now becomes less than or equal to 0. And for today, I'm not going to make you graph that solution. But notice, both of these got me 0. So this special case is a 0 solution. That means the number 0 is the actual solution. Sometimes you get 1, 2, 3. This time we just get 0. Okay, so the next part of this is going to be solving this equation and this inequality, and we're going to see what kind of special case we get here. So we're going to start again by just boxing our variables and drawing our lines. And now you'll notice that we have variables on opposite sides. So remember, when you have variables on opposite sides and you have no like terms and no distribution, you have to combine them. So if I want to move this 2x to the other side, it's a positive. When there's no sign, there's like a little imaginary plus sign. So I'm going to subtract 2x. And if I do it on this side of the equation, I have to do it on this side of the equation. But when I do 2x minus 2x, it's just 0. I'm not going to put 0x. These are just going to cancel. I'm going to get negative 1 because that's all that's left equals. Well, these we know cancel out. And I'm going to have positive 4. So I don't have to write the plus 4. Well, now when I get here, there's really not much else to do. Does negative 1 equal 4? No. Negative 1 is not the same as 4. So this is not true. So when you get to a situation like this, and the variables completely cancel, okay, the variables cancel on both sides, okay, that's going to mean that there is no solution. That means no matter what, there is nothing that you can substitute for x on this side and x on this side that's ever going to make this equation true. So your answer to this is no solution. So it looks like the variables cancel. That's your sign. So if you end up with just two numbers, that's no solution. So let's see how similar this looks for an inequality. So if I can box all my variables. There's no distribution, so I don't have to do anything like that. But if I look, oh, there's some like terms on this side. So in your calculator, this is where some people kind of type the wrong thing. You type what you see. So I see a negative 1. And then I see a minus 3, not a negative 3, a minus 3. So you have to make sure you're typing in the right stuff, and you're going to get a negative 4p. So I can bring down the plus 24, bring down my inequality, and bring down this side because I didn't use anything on it. Okay. Now I can box my variables again. Now I only have one on each side, and I have no like terms over here and none over here. So I can start to move the negative 4p, and I move that by adding 4p. Remember, you have to do the opposite. And what you do the one side, you do the other. So I have 19. Well, again, negative 4 plus 4 goes away. I don't write 0. Bring down your inequality. And then again, it happens over here, and I have 24. So let's read this. This says 19 is greater than 24. Well, that's not true. So this is not true again. And what do you notice, right? Over here, we are left with just numbers. Over here, we're also left with just numbers. So the variables cancel again, which means, yep, no solution. Now, you can't just leave it on your answer sheet. You can't just leave it like this and box this. You have to write the word no solution. So this might be where you remember stuff from last year, and you might be thinking, oh, I think I know what this one is called, what's going to happen here. So let's see if you're right. So if I'm looking at the first one, let's follow the same tactic. So here's a variable. Here's my line. Here's another variable. Here's another variable. Oh, what does it mean when there's just a variable and no number? That means there's an imaginary number in front of it. Remember, it's always a 1. So I always say add a 1 so you don't get confused. So on this side, there's no like terms. But on this side, there is. There's a 1b minus 6b. So if you do 1b minus 6b in the calculator, you're going to get negative 5b. We can bring down the 1, the equal sign, and we didn't do anything over here. Well, whoa, what do you notice right here? 1 minus 5b equals 1 minus 5b. Huh. All right, it's the same. Okay. That's weird. Let's keep going. So if I box these variables now, I need to just move them get them on the same side. So the opposite of subtracting 5b would be to add 5b. So I get 1. Oh, wait, again, negative 5b plus 5b. Huh, okay, equals. And, 1, and again, it happens. So they cancel again. So wait, I thought when my variables cancels, that means no solution. But when I look at this, what does it say? It says 1 equals 1. Well, is having a dollar the same as having a dollar? Yeah, 1 does equals 1. This time, this is true. So yes, my variables canceled, but this time it was true, right? Rather than not true. So that means there's 2 ways you'll see this. You'll see the answer is all real numbers, or you'll see infinite solutions. That means there's an infinite amount of numbers, okay, that I can substitute in for B on either side, and these will match up. And you notice this was the same, this was true, and this was true. So you could kind of stop here, but you can always keep going. So this one is infinite solutions. So let's see what it looks like for inequalities. Should pretty much look the same, right? So here's my variable. Here's another one. Here's my line underneath my inequality. But this time, I do have a distribution. But again, there's no number. So remember, when there's no number and there's just a sign or just a letter, that means there's an imaginary 1. So that means I have to distribute. Distribute means multiply. So I have to do -1 times +2, gives me a -2. -1 times +5x gives me -5x, greater than or equal to, and we'll recopy this side because we didn't do anything to it yet. Okay, let's rebox our variable. No like terms, so I'm going to move the -5x to the other side by adding 5x here, and I'm going to add 5x here. So I have -2. Oh, again, these are canceling. Bring down my sign, greater than or equal to, -2, and these cancel. Well, if I look back, this line, -2 minus 5x, was the same as -2 minus 5x here. -2 greater than or equal to -2, it's the same here. Is -2 greater than or equal to -2? Yeah, it's equal to it. So I'm back at a true statement again. So what does that mean? That means it is infinite solutions, or all real numbers. So you'll notice that whether it's an equation or inequality, they look the same. So go ahead and start your activity.